Exercise 3.3. This is where we finally get into writing out whole truth tables. We'll do some of the odd numbered problems since the even numbered ones are assigned for homework. I've written out the truth tables in advance, and I've filled in the values on the sides, and also I've highlighted the main operator. Those are all things that you should be getting pretty good at with all the practice. I should also mention, if you ever see any mistakes I make in these videos, please point them out in discussion so I can get them fixed. I don't want to mislead people and give wrong answers, so definitely do that. Now you notice, as I talked about in the last video, truth tables are different sizes depending on how many different atomic sentences. So for numbers 3 and 5, number 3 is J, conditional, not J. So there's only one atomic sentence in that whole formula, namely J. And that's why we only need 2 lines, because there's only 2 possible values J can have, either true or false. Same with number 5. We have not, parentheses Y or not Y. Again, Y is the only atomic sentence that occurs in the whole formula, so that means there's only 2 lines in the truth table, since Y can either be only true or false. Number 7, we've got A and B. We've got A conditional, not B. So that means we have 2 distinct atomic sentences. And again, 2 squared, right? So you take 2, you raise it to the power of how many different atomic sentences you have. In this case, 2. So 2 squared is 4. So that's why we have 4 lines in the truth table. Same with 9, we've got R and S. So we've got 4. And then finally, 11, we've got 3, A, S, and E. All right, so that means we have 3 distinct atomic sentences. So 2 to the 3rd power is 8. 2 times 2 times 2 is 4 times 2, which is 8. So that's why we have 1, 2, 3, 4, 5, 6, 7, 8 lines in this truth table. Now the construction of a truth table I covered in one of the videos pretty extensively, but just a quick review. You should generally put these in alphabetical order. Sometimes in the textbook he doesn't. In this case he didn't. He put S before E. It's not a big deal, but it just makes, if everyone writes the same truth table, it makes it a lot easier to read them. So generally speaking, you should put your atomic sentences in alphabetical order, starting from left to right. Then the leftmost column, you go half of them true, half of them false. We know this is an 8-line truth table because we have 3 distinct atomic sentences. So the first 4 are true, the last 4 are false. Then as you move into the next column to the right, you alternate twice as much. So here we alternated every 4, now we're going to alternate every 2, starting with true. So 2 true, 2 false, 2 true, 2 false. Then as we move into the next one, we alternate twice as much again, which means every 1. So this one goes TF, 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 TF. All right, the first line of your truth table should always be all true. The last line should always be all false. And your innermost column should always alternate every time. TF, TF, etc. All right. Okay, so let's go back over here to 3. So if J is true, obviously that gets a T. That gets a T. The negation has the effect of false, turning the true sentence false. So now we've got a conditional, true, antecedent, false, consequent, which means conditional is false. On this line, we've got false antecedent. Oops, I'm going to do that. So this is false, but the negation turns it to true. So now we've got false antecedent, true consequent, which means that is true. All right, so entire row. All right. So now we have to decide, is it a tautology, a contradiction, or is it contingent? All right, so quick definitions. A tautology is a sentence that comes out true on every line of the truth table under the main operator. So tautology is always true. A contradiction is the opposite. It comes out false on every line of the truth table under the main operator. So you can see this is neither tautology nor contradiction. The other option is called contingent. which means it comes out true at least once and comes out false at least once. So this comes out false once on the first line, true once on the second line, so it is a contingent sentence. All right, number 5, why? We've got true on the first line, so it goes true there. This negation flips that to false. So inside the parentheses, we've got T disjunction false, which is true, since the disjunction is true as long as one disjunct is true. But now out here, we negate that true, and we get false. Second line, false, false. The negation flips that to true. So again, we have false, true. As long as one is true, we get true inside, and we negate that, and we get false. Now, this sentence, why or not why, is a tautology because the principle of bivalence says every sentence is either true or false. So either why is true, or not why is false. But once we negated it, we turned all those trues to falses. And again, a sentence that has all values false under the main operator is called a contradiction. All right, 7. First line, we've got true, true. This turns it to false. So we've got true antecedent, false consequent. We know that means the antecedent or the whole conditional comes out false. Here we have true. This is false, so this comes out. So not becomes out true. So we have true antecedent, true consequent. That comes out true. Now, as far as determining what kind of sentence that is, we can pretty much stop right there, right? Because, again, if it comes out false on at least one line and true on at least one line, then we know it's a contingent sentence. But I'll continue to fill this out just for completion's sake. All right, so here we have false, conditional false, which is true. And again, here we have false, false, so we end up with false conditional true, which again ends up as true. All right. So number 7 is contingent because it has at least one F and at least one T, right? And notice that this is only one F, but that doesn't matter. As long as there's at least one of each, it is a contingent sentence. All right, number 9, we've got, again, 2 atomic sentences, R and S. So the first line, R is true, which means not R is false. And then if R is true and S is true, that means their conjunction comes out true. So now we've got a disjunction with one false disjunct and one true disjunct, and as long as one is true, it comes out true. So the first line, that sentence comes out true. All right, here again we have true, R is true, so then not R is false. Here we have true R, false S. It's a conjunction, so if one of them is false, the whole conjunction's false. Now we have false, false, which gives us false. So again, as far as determining what kind of sentence that is, we can pretty much stop there because we've got at least one T and at least one F. But again, we'll go finish for completion's sake. So if R is false, not R is true. Here we have false, true, so it's going to be false. So we have true, disjunction false, which gives us true. Last line, we get a true, the first disjunct is true, so we know it's going to come out true, even though what's inside the parentheses here is false. Okay, so again, as long as we have at least one F and at least one T, it is a contingent sentence. Now, if there's any confusion about where I'm getting these letters, right, any column that has an R here should look exactly like this column because you get the value from over here. These first 2 columns are like the key. They're the ones that are listing the values, right? There's 4 possible values for a combination of 2 atomic sentences, both true, true false, false true, or false false. right? So this R column looks just like this R column, but then when we apply the negation, it flips it, right? Same here, R, T, T, F, F, S, T, F, T, F. Now we apply the conjunction, we get T, F, 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 all right? So that's where those values are coming from. All right, last one is 11. Again, this is 8-line truth table. And first line, we've got T, right? So S is true on this line. A is true on this line. And so the conditional is true. Oops. Again, S is true. E is true. So the conditional is true. So we've got a disjunction with 2 true disjuncts, which means that whole sentence is true there. Second line, we've got S is true. A is true. So this one comes out true. S is true, but E on this line is false, right? So we put false, and we have conditional with true antecedent, false consequent. We know it comes out false, and now we've got true, false. But again, as long as we have at least one true in the disjunction, the whole disjunct comes out true. All right, so here we have S is false, A is true. So when the antecedent is false, the whole conditional comes out true. Again, that's going to give us a true disjunction, because as long as at least one disjunct is true, the whole thing would be true, but we'll fill out the whole thing just to be complete. So here we have false true, which gives us true. All right, here S is false, A is true, so that comes out true. And our whole disjunction is going to come out true. S is false. E is false, so this comes out true. So again, we've got 2 true conjuncts. Starting to look like we might have a tautology. It's definitely not a contradiction, but it could still be contingent, so we have to keep going. So here, S is true, A is false, and so that gives us a false conditional. Over here, S is true, E is true, so that gives us a true conditional. And again, as long as at least one of them is true, the whole disjunction comes out true. So still could be tautology, could be contingent. Here we have S is true and A is false. So that means the conditional is false. Here we have S is true and E is false. So that gives us a false conditional. So now we have 2 false disjuncts, which means that whole sentence comes out false. All right? So now, again, we know for sure that this sentence is contingent because we have at least one true and at least one false. So as soon as we find that one false, we're done as far as determining if it's contingent. Let's just finish though. Here we've got false S, so the conditional is going to be true, and that'll be true. So we've got false, true, and then E is true here. And then this last line, false, false, will give us a true conditional. And same here. All right. So that's the whole thing. You can see this has 8 lines, only one F. All the rest are T's. But it doesn't matter. As long as you have one F and one T, it's contingent. All right. So that's how to do truth tables for whole sentences. I think the biggest one is 8 lines. You can go bigger. You can go 16, 32, etc. So if you have questions on the video, post it in the relevant discussion room.